Well, howdy there, Internet students. It's Mr. Hermanson again. I thought I'd go over some of the frequently missed questions from Practice 10.6. Number 27 was one that not too many students got right, so we'll start right there. We're going to find the area of the shaded region. Let's start with just this part right here. That would be 240 degrees out of 360 times the area of the whole circle, which would be 9 squared pi. And then we'll get the area of that triangle and add it on in a second here. So for that part, you get 54 pi. Now we're going to add the triangle. Now the triangle, I'm going to just redraw it here a little bigger. This is 9, this is 9, and this is 120 here. Now if we wanted it exact, you might notice that this, if we split it like that, that would be 60 degrees there and 30 degrees there, which means the height of that triangle would be half of the hypotenuse, which would be 4.5 for the height, half of 9. And then the base would be 4.5 times the square root of 3 for just this part. And so we got to double that for the base. So we get 9 times the square root of 3 for the base times the height, which is 4.5 times 1/2. And that equals 20.25 times the square root of 3. And then it says round your answers to the nearest tenth, so I'm going to keep that all 1 and just round it to the nearest tenth. And I get 204.7. All right, another problem, number 43. We need to find the area of that segment. Now, to do that, we're going to do the area of the sector, which is, I think, 300. That looks like a 60-degree angle right in there. So we have 60 degrees out of 360, which is 1/6 of the entire circle, which is 7 squared pi. And then we need to subtract the area of the triangle. Now the triangle looks like this. It's a 60-degree triangle. The sides are each 7. Let's go ahead and use that. Since we're rounding to the nearest tenth, let's use the 1/2 sine AB. So 1/2 times 7 times 7 times the sine of C, and that would be a 60-degree angle. All right, and then I'm just going to put all that in and calculate it all at once and round to the nearest tenth. And rounding to the nearest tenth, I get 4.4. All right, number 44 was also a problem. So once again, we're going to find the area of a segment. So we're going to find the area of the sector right there, which is, let's see, I think the radius is 8 there. Correct? And that's a 120-degree angle. So it's 1/3 of the entire circle. 1/3 times 8 squared pi, which is 64 over 3 pi. And then we're going to subtract the area of the triangle. The triangle looks like this. It has a 120-degree angle, and both sides are 8. Let's go ahead and use that formula with the sign in it for finding the area. So we're going to do 1/2 times 8 squared times the sine of 120. And go ahead, let's subtract those two and see what we get. And rounding to the nearest tenth, I get 39.3. All right, hope you find this helpful. Good luck.